Hey everyone, thanks for joining us. I'm just going to give everyone a second here to log in, but I'm excited to have you guys here and we'll start shortly. All right. Good morning, good afternoon, wherever you guys are joining us from today. We've got a great webinar co-hosted by the New York Oracle User Group and Oracle partner Viscosity North America. This is a live webinar, so be sure to submit questions in the Q&A field, and our presenter, Monica, today will get to your questions as she can, and that will be throughout the presentation if she can as well. So please go ahead and just start asking questions as you think of them. So we do have an amazing speaker for you today. She has spoken for us before, so hopefully this isn't the first time you're seeing her. All right. So I'm going to introduce myself real quick. My name is Monica Lee. If you're not familiar with me, I'm the marketing director here at Viscosity. We are a full Oracle Stat consulting firm in the US. So I'm co-hosting today with Coleman and Rob from the NYOUG. Coleman, I'm going to let you go ahead and tell us a little bit about NYOUG before I talk about Viscosity, and then we'll kick off.
Absolutely, Monica. Thank you again for the kind introduction. So the New York Oracle Users Group was formed, I think, 40 years ago, over 40 years ago, for the exchange, ideas, assistance, and support among users of Oracle software products. And you can reach out to us on nyoug.org, on Twitter or X. I keep referring to that old name. Uh, Actually, all social media, we have a social media presence. And I just want to thank Viscosity for this co-hosting these series of webinars. It's been going on since uh, a little over 5 years now, and we're going
That's
strong. Just
crazy. I
incredible
can't believe
that it
that.
just went a snap of the fingers. And Meetup and everywhere else. So look on our website, NYOEG, for past webinars, presentations that we've had co-hosting with Viscosity. Thank you,
Thank you
Monica.
so much, Coleman. Yeah, I can't believe it's been 5 years now, which is insane. Almost to the dot, probably. So,
Yes.
again, my name is Monica. I work for Viscosity, and it is our mission to enable business transformation at a time when companies must change to survive. I know tech, everything moves fast, the economy, everything is constantly changing, budgets, new solutions, things like that. So it's companies like Viscosity that are there for you when you need to figure out, what a new game plan might be, what new products may be, and how it might fit in your budget and your solutions. So definitely reach out to a partner near you or a partner you trust, and make sure your company is taken care of. So on the screen, I like to always point out our main three pillars that we are built upon, and that is data, apps, and infrastructure. So down across the bottom, you can see a variety of services we offer across all three pillars. Services included with our proven solutions and professional services could include assessment health checks, proof of concepts, training, you name it. Especially in times like this, staff aug often becomes very popular as well as teams kind of grow or shrink very quickly. So you can keep that in mind. All right, these are some of the books that we have written. I think our team has over 30 books under um, the Viscosity umbrella. So hopefully you own some of these, but they're kind of across a bunch of different things. A couple of our newest books are on performance tuning and let me see what else. Upgrading databases. And I think the Docker one is from a year ago, maybe 2 years ago. But a lot of my writers are Oracle Aces. Hopefully, you're familiar with the ACE program. Viscosity is very involved in the Oracle community, especially with user groups like this. And these Aces are typically always at some user group across the US, speaking occasionally overseas, but definitely they are always somewhere at a user group conference that you can go check them out and see their sessions. All right. Some services we provide. The only one I really like to point out here is license management. just because I think people forget we do this. We are a consulting firm. We are here to help you with solutions and, you know, projects on site or remote. And I think it's often forgotten that we also just do resale and we can help you figure that out. It's, you know, something that's kind of hard to navigate if you don't have to do it very often. So since partners do it fairly often, we can help you get better discount and rates, help you understand the paperwork, help you understand all of the things that go with it. So just let us know if that's something you're interested in, even if it's just to see quotes in comparison. So other than that, we do have AuraPub powered by Viscosity, and this is where we house all of our webinars, and that's recordings and slide decks. Anything that we do, even with a conference or something like this with NYOUG, they're all posted there. You can also see today's webinar at nyoug.org, so you do have that option too. I do recommend signing up at AuraPub as at least a free member. There are a couple different tiers, but the free one gives you access to every single free webinar like this that we have participated in, and yeah, you just have access to so much free training. So why not? So check that out. And otherwise, I think I'm going to turn it back over to Coleman. We do have a lot of great webinars coming up for you guys throughout the summer, I think already scheduled. So stay tuned for those if you haven't signed up for any already. But otherwise, Coleman, I'd love for you to introduce Monica, and we'll talk to everyone soon.
Thank you, Monica. So Monica is an experienced Oracle architect, designer, and developer. She started her journey with Oracle in the last century. Last century. Wow, it's only a few years ago with Oracle DB7 continuing to this day. She emphasizes the solution simplicity, code quality, best practices, and above all, system performance. She's an Oracle ace and willingly shares her experience. She loves fast motorcycles and databases, and may I add, cooking marshmallows, as you can see by the video. Thank you again, Monica, and thank you, Viscosity, for these series of co-hosting a series of webinars with us for the past 5 years and going strong. Please take it, Monica.
Thank you very much for introducing me, and thank you for the invitation, because I've been here three years ago and it was amazing. So I'm really, really happy that I can be here once again. And thank you all who joined my session. At the New York NYOUG, you have at the meetups or webinars, you have a great opportunity to see a lot of presentations discussing performance and some deep down knowledge about Oracle and so on, so on. But I want to start today with something else. And I would like to encourage you to look at both sides of SQL, the good one and at the other one, the evil one. It's interesting. I don't know if you've seen things like that, the SQL can have a can be good for performance. It's great, but on the other hand, can have huge impact on the same performance, but somewhere else. So at the one part of system, we tune our query and it's fantastic, it's fast as hell. But on the other hand, on the other end of the system, everything is very, very slow or slowing down. So knowing about good and bad sides of SQL helps us to avoid those traps. So let's start from the beginning, and I'm the beginning. So once again, my name is Monika Lewandowska. I'm Oracle Ace Pro, and I'm a member of the Symposium 42 organization. As Coleman said, I'm an Oracle designer and developer since the last century, so please do not count how long ago it was. Well, I really like the performance stuff and things and tunes some SQLs. And really, I have a lot of experience with the whole computer thing. And My hobby is riding by motorcycles, and I have a lot of experience with the whole motorcycle thing too. So you are in good hands. Symposium 42 organization is the organization created by community or a community to support the community. And if you want to know something more about this, you can visit our website, sim42.org. But let's start with our SQL. So SQL is great, right? It's quite old because it was created in 1970s, and the first standard SQL 86 was created and designed in 86, and this SQL is still developed. So SQL is one of the most powerful languages, and it gives us direct access to the database. We can manage the data, change, query, or delete them, analyze the data. We can also have a good performance, of great performance of our queries using this SQL. We can even have the direct access to the PL/SQL from the SQL. So we can mix SQL and PL/SQL, right, in PL/SQL code, or we can mix PL/SQL functions in our SQL queries. So it's one of the best feature of Oracle. So it's very, very powerful, and we can, of course, process all our data in our databases, Oracle databases, using both SQL and PL/SQL. So it's amazing, it's awesome, it's fantastic. But so if SQL is so great, why do we have some performance problems? Do you have performance problems? I think you have, because you are here. So maybe we have to take a closer look and see some problems and the ways how we can fix them. So hi, we have a performance problem. So what we can do? Maybe we should start and try turning it off and on again. It's standard thing, and we can do it, try this, but it's not working this time. So what we can do? Our queries are still very, very slow. What we can do to fix the performance problems? The first thing which comes to our minds is usually indexes, right? Do you agree? You're off. So let's see some indexes, right? I create the empty EMP table as a copy of employees tab. Employees schema is the standard schema in Oracle databases for trainings or education, and I use it for my usually for my presentations and webinars. But the details are not important here. We have some queries: the table, EMP table, empty table. And what I want to do is to insert 10,000 rows to the table. Let's do this. Okay, this is, don't look into details. I show you that we load here in a loop 10,000 rows, right? And elapsed time is 0 seconds. So it's quite fast, but we have some query, right? We have 10,000 rows, 10,700 rows here in the table. And in our application, we have the queries like this. Select count from EMP where last name equals king. And this query is very, very slow. What we can do? We can create an index. Of course, we have table access full, right? And to make it better and faster, we can create an index. Let's try this. Okay, simple index, create index on last name column. We have created, and we can check explain plan. And the query is fast at her. It uses index and it's very, very fast. But we have more queries which are very slow. So what we do usually, we can create more indexes. And it's fantastic. Our queries are very fast. Users are happy. We are happy. But now we need load another 10,000 rows. Another process, ETL process, loading data process. And we have the same process, the same procedure to load our data. In a loop, we load 10,000 rows. And we wait. Oh, this time, I didn't change anything in my loading process, but this time I have the elapsed time is 10 seconds instead of 0 seconds. Why? Well, the problem with indexes is that it's very good for queries and performance of queries. But on the other hand, every time we load the data, we insert data, we modify data, delete the data even, Oracle has to change indexes too. So if we have a lot of indexes, this can be really, it can have a bad impact on our loading processes. So we have to be careful and create indexes only then when we really know that it is important and we really need it. I've seen one system where in every table has at least as many indexes as columns. So for example, there was a table with 30 columns, and on this table was, for example, 33, 35 indexes. And believe me or not, but this system had a lot of problems, performance problems, especially in the places where they inserted data or modified data and so on and so on. So yes, this is a huge problem sometimes. You have to be careful with indexes. What we can do if we suspect that that we may have such a problem, we do not have to do anything because Oracle on our behalf has tracked our index usage. So Oracle knows if we use indexes or no, and we can check it using looking in some views. For example, $index usage info. We have information about active element count, last flash time. This is information about this index usage tracking and what we have here. For example, we have information about if index stats statistics are enabled or index stats collection time. This is the parameter stat collection type. What does it mean? 0 means all and 1 would be sampled. What does it mean? Oracle tracks our indexes. Usually this sampled is default. So it's from time to time checking if we use some indexes or not and write it down. So we can use this to check if we have a problem. But to see what indexes are useless, we should change this parameter to all. This means that Oracle tracks all our indexes. So this parameter is just to check if we have a problem and we should go deeper in the investigation. And if we want to really check if indexes are used or no, we should change it to collection type all. What we have in this table view, we have index name, and how many times it was accessed, how many times it was executed, what's the difference with between access and execution, access is, for example, how many times Oracle uses this index, and this total execution time is how many time it takes data from this index. You can think about this like a nested loop. So you have one query and we use only one index here. This is the access, but because this is nested loop, we execute this index many times within this one query, right? How many rows this index returned, and when last time this index was used. So this is really interesting information, and we can check just for now. For example, if we suspect that we have a problem, we can check if all our indexes are used or no, or maybe we have 100 indexes, but in these views we have only 3 or 4 indexes. So we can check if we have a problem. And maybe drop some indexes, but you should be very careful with this. Okay, we have really fast queries right now, right? Indexes speed up our queries, but can slow down our DML, our updates, inserts, or deletes. And to find out which indexes are used or not, are not used, we can check in index usage tracking. Okay, we have a very fast query right now, but we need to tune our ETL process now. So we tuned our queries, but our ETL is quite slow. We tried turn it on and off again, but it doesn't help. It didn't help. So what we can do? Usually when many times I've heard that if you want to load some data to database, you should do this, if you can, in pure SQL. So we should do this in SQL. Let's try to create some ETL process with SQL and we see if it's really fast. Okay, I create empty table once again for this demo. And let's start with loading some data. Oh shit. Check constraint related. Yeah, it worked on my machine. I'm on my machine. So what happens here? I hope we fix it eventually. Okay, we have zero rows. We have to fix it. Maybe you can help me with fixing this stuff. Okay, I don't know. You have here 10,000 rows to investigate, so it would be difficult, I think. And well, this is what usually happens when we want to load some data using pure SQL. Because if we insert data and we have some errors or rows are incorrect, and all SQL or insert stopped. So we loaded 0 rows. So now we have to fix it, find the record which is incorrect, fix it, and do the process once again. So maybe one insert is very fast, but if we add to this errors, fixing the errors and reload data and again error, finding the error, fix this and reload data and so on, it may be quite long. So maybe we should do this in PL SQL with exceptions and so on. Maybe it would be better. But there is a third way, DML error logging. What's this? this is a feature. This is a quite old feature, but it's very useful that we can use insert or update or delete. And we, at the same time, we can track all errors. Let's see how it look like. So first we have to create tables for every table, our source table. So I create here error table for EMP table. And then I can load my data, but this time I add this clause, log errors, some text. This is my string to find these errors in the table, and reject limit unlimited. Reject limit means at which error it should stop. So for example, we can have reject limit 10. So when there is 10 incorrect rows, this stops. And usually we use unlimited, so it will be inserting data until the end. So we see that we have 10,600 rows inserted. So it's more than 0, right? We can check it. We loaded 10,000 rows to our EMP table. And then we have, we can look in EMP table. It's our table with errors. We have here 10 rows, 100 rows. And in this table, error table, we have message, error message. So why or I couldn't inserted this row, our text, this tag, and whole row. So for example, employee ID, last name, first name, job ID, etc., etc. So based on those information, we can easily find which all rows which ended with error, and we know why, and we can easily fix them. Right? So SQL YAML is very, very fast, and we should do every loading in pure SQL if we can. Sometimes we can't, but it stops if there's an error and it's hard to find and fix wrong record. So we can or do our loading process in PL SQL, or just use DML logging clause to track our incorrect errors, incorrect rows. Okay, we make our ETL a little bit faster, but it's still too slow. Turn it off and on again, it's frustrating advice. So the best solution for all performance issues, so when we are talking about inserting data to the table, to the database, is, I don't know if you heard about this, but it is hint append. What's this? Hint append is the feature which allows us to bypass buffer cache and reduce read and undo writes. So this is the direct path. So we can easily load our data, and it's really, really fast. Right? So let's try this once again. I have a EMP table, empty table, and I create some more tables for our demo to show you something. And let's try load some data. Okay, I have this time I have just insert as the same as before, and the time is 0. Let's assume that's too long. So we can add our, we loaded 5 types and rows. So it's too slow, so we decided to add append hint. This is direct path. You can just add the hints to your insert with append or append values name and wait. 17 seconds. So it's weird because the minute ago I said that this is a lot faster than simple standard insect. The conventional path, this direct path should be really fast, but it's slower. Why? We loaded also 5,000 rows, so this is the same, right? With also 5,000 rows. So the problem with append hint is that if we load data using this append hint, it insert the row always above high water mark. I don't know if you heard about high water mark, but high water mark shows it's the pointer and our blocks. It shows how far into the table data has ever been stored. So, we add row to our table space, and Oracle marks that we have this many rows here at this block. This block is not empty. So we add another row, and it marks this block that we have rows here, and another. So this is the information for Oracle how many blocks has data, right? So the problem with direct path is that it always added the row or rows above high water mark. So imagine that you insert one row at a time, and Oracle marks this block and put their high water mark. So in a loop, another row, only one, and high water mark, another one, and high water mark, another one, and high water mark. And at the end, you have only one row in every block. But now calculate the math. For example, average row length is 80 bytes, and your block has 8,000 bytes. So more than 90% of this block is empty. If you use append hint, inserting one row at a time. And you can see here, emp table, when I loaded data just row by row, regular insert, it uses only 64 blocks. With append hint, 5,500 rows. So this is huge. And I've seen situation like that. One time the developer came to me and asked to take a look at some SQL and some query because it's very slow. I started to look at this and I noticed that one table has a full table scan. So I asked if it is a big table, small table, how many rows are there? And the developer said, oh, it's a big table. I asked how many rows is there? And he said, I don't know. So you don't know. So how do you know how this table is big? Oh, it has 4 gigabytes table space. Okay, 4 gigabytes. So couple of rows could be there. Then I started to tune the square or do something with this, trying to figure out how to help. But I still had in my mind the question, how many rows are in this table? And I had to try and check this, and typical select count from table, and it turned out that in this tab is 3,000 rows, and it needed 4 gigabytes to store 3,000 rows. 3,000 rows, it's nothing, and it wasn't very long. It just 10 columns or something. So it was really interesting, and I tried to investigate it, and I found out that in loading process, they did exactly what I showed you. They inserted row by row using direct path, so append hint. So in this project, in this database, every 8,000 bytes block uh, start only one row. So what we can do about this? First of all, we should never ever load data using hint append and load only one row and at a time. Never ever. We can just rewrite this code, and we can use for all and use insert append hint to insert all of data, at least, I don't know, 100, 1,000 rows, or we can use insert as select feature, but never ever do like this. And this time, as you see, it's that the elapsed time is 0. And we loaded 5,000 rows. And this time, EMP for all plus append also uses only 64 blocks. So it's good. But how to check if this direct path was used? It happens to me that I've seen in one project that the developers used append hint trying to make loading process faster, but they did it this way, so row by row, row by row. So I told them that maybe it's not the best idea, but they didn't want to change it. But I noticed that they used that the hint would be ignored. And sometimes this hint append can be ignored, and I show you in a moment why. But how to check if this direct path was used? Let's see. I have this insert a select, and I added append hint here. And we can see execution plan. In execution plan, you could see load and select as select, right? Operation. And it means that this direct path was used for this query. And another verification can be that you cannot query this table until you commit the transaction. So I didn't commit my insert, so I can't query this table, right? Cannot read or modify an object after modifying it in parallel. Except you have 23 version of Oracle, because in this 23 AI you can query the table in this situation. We can commit, and then we can query the table. What if we have a trigger on the table? Let's create the trigger, just doing null, nothing. Let's insert some data with append hint. So we want to use direct path, this fast path. And let's see, we don't see here load as select. We see here load table conventional. It means that this query doesn't use direct path, and we see also a note direct load disabled because trigger are defined. So this is the same situation with this situation with my friends, where they used the append hint direct path in the process row by row, but they had a trigger on the table. So I said, okay, they will be fine. it will be not, this hint will be ignored, right? So we can select the query. So this was a conventional path. We didn't use, it didn't use the direct path. Of course, we can disable all triggers. And if we disable triggers, we can use direct path. So if we need this direct, if we want to use the direct path, we can, for loading process, disable the triggers, load data, and then enable triggers at the end. Right, we loaded 10,000 rows. Interesting thing is that we can have triggers after update event. If we have trigger on update, we can use direct path as well. See, load as select. So we insert data using direct path. We cannot query this table until commit, and now we see we have 16 rows, 16,000 rows. And another way to make Oracle ignore our append hint is to create foreign keys on a table. If we have foreign keys on the table, this append hint also will be ignored. Let's try. See, load then conventional. So conventional path, not direct path, and we have a note, direct load disabled because parent referential constraints are present. So it's really essential to check, for example, execution plan or so, because when Oracle decides to ignore our append hint, there is no warning or error. It just ignores, and we even don't know if it used the append hint or no. So it's better to check it. Of course, we can alter table, disable all constraints, and then we can use direct path. Right? But it is really, really fast. But there's also the problems with the direct path, because it's always added new rows above high water marks. We have to disable triggers or disable foreign keys. And what's very, very important that because Oracle reduces redo and undo writes, it's not possible to recover the data after the crash. So we may use append hint on direct path only when we know that we can easily reload those data from the source. So we shouldn't use this append hint direct path for very sensible data in our system. This is just for ETL or something like that. But it is very, very fast. So as I said, we can't use append hint everywhere. We can't use direct path everywhere because, for example, we have sensible data and we don't want to lose them. So what we can do? Maybe we should use old bulk collect and load data, not row by row, but all at once. Let's check how we can do this. Okay, I created and once again EMP table as a copy of employees, but this time I have a little bit of data here. I have employee ID, index on employee ID table, and what I want to do right now is to calc a pay rise for our employees. This is the typical process. So I need some employees information. I need employees row from EMP table for our employee ID. I have to do some processing here. Then I calc my new salary. This is salary plus some percentage. It doesn't matter. The details doesn't matter. And at the end, I update the row. Then I have the process to process all my employees. So I have a loop and I run process employee for employee ID, right? And elapsed time is 2 seconds, almost 3 seconds. But well, we want to make it faster, so we want to use bulk collect and for all. Let's add this to our process. So instead of a loop, we have bulk collect in our query, right? Bulk collect into collection. And there we have, instead of update, we have for all. So it should be faster. So let's run it. Of course, we want to process all our employees. So we have a loop and we run our process for all employees ID. But it's slower, not faster. It's slower this time. Why? I said before that bulk collect is really fast and we should use it instead of processing row by row, right? So what happens? If you look into our process, you could see that I use bulk collect and this query, but I query only one row at a time. And because I query only one row at a time, of course, I update only one row here as well. And this is why it's slower, because it is the same thing as the previous one. So inserting row by row, processing row by row, but additionally, org has more work to do because it has to do some things which are needed to bulk collect it or for all it, right? So this is the same thing with as with direct path. We shouldn't use it for processing only one row. It's slower then, not faster. And all my examples are taken from real life. So really, I've seen this in real project that they used bulk collect to query or update only one row at the time. And really, it wasn't fast. So to change it, we can rewrite our process, and in process employee, when we calc new salary, we have only algorithm. So rec salary equals salary plus commission. It's a mistake with algorithm, but doesn't matter. And we should use bulk collect and for all at the level when we process all rows. So this starting procedure, when we query all employees and run the process for one employee. So here we have a cursor for all our employees from EMP table. We open this cursor, we fetch this cursor using bulk collect. And then we can use for all to update 1000 row at a time. And this time it took 2 seconds. So a little bit faster this time. And the advantage of bulk collect is also that it reduces context switches. What's that? When you mix SQL and PL SQL, the context has to be switched because this is not the same language. Oracle has 2 engines. One is SQL engine, which interprets and understands SQL, and another engine is for PL/SQL. So the engine which understood PL/SQL. When you mix SQL with PL/SQL, those 2 engines have to communicate and talk to each other. So this is, if you have SQL in PL/SQL, you have still the context switches. So you shouldn't use SQL, for example, in a loop in PL/SQL, because you will have a lot of context switches and it's quite heavy. So it can have a bad impact on the performance of your PL/SQL. If you use bulk collect, you can query all your data at once. So we reduce this context switching. But you can benefit only when you have really bulk processing, not row by row processing. Have time? We have time. So we have now a new system and we use the API because we want to reduce the context switching, or we have the system which is really nice to read and understand and maintain. So we created the system really designed with good design, but it's very slow. We must investigate this. Okay, last example. Be careful because there's a lot of code right now. I have another one. I create a table for this example. And what I want to do is the similar thing as previously. I want to calculate new salary for our employees, but this time I will add the configuration to our table. So we have employee salary in EMP table and column salary, and the configuration will be in departments table. I added pay PCT column, and this is my configuration. So the percentage of the pay rise, right? And this is the algorithm. I update the departments table to say random values in my new configuration column. So IT department will get 2% of pay rise. And we have our packages and procedures to process our pay rise. What we need, first of all, we need the salary from EMP table, right? Then we have configuration from department stay by PCT. And then, and to get the configuration, we need also the department ID from employee table. So we need a function get dept ID. And the code for function get salary. We have query to emp table to get our salary. We have another function get pay PCT. So we get our configuration column from departments, where department ID is the we can get this department ID using the function getDeptID. So we need find the department ID for this employee ID in EMP table. Okay, so this is our APIs, and now the procedures to process our pay rise, procedure calc pay rise for EMP ID, and main process to run for all employees. This is it. So this is our calc pay rise procedure. First, we get the current salary, then we can get our percentage from department configuration table. We calc new salary, and then we update the EMP table, our employee, with the new value of salary. And then we run this process for every employee from EMP table. Let's run it. Okay, 3 seconds. And what's interesting, as we can see, we had to query departments table 5,000 times, EMP table more than 10,000 times. This is how many queries we had to do against these tables. And we had 5,000 updates on EMP table. And this is really, really simple scenario and really simple functionality. And so many queries. How can we change it? 3 minutes, okay. We can use some collections, PL/SQL collections. For example, this is the associate collection, right? Department row type indexed by PLC, the PLC integer. So I have one collections for department table. And what I want to do is load all my configuration to the collection at the beginning of the process. So I don't want to query this table all in every single loop, iteration of the loop, but I load this configuration only once, load data from department table to the collection, and I will use it just like that. Just not instead of query, I take this configuration from a collection, tdept collection, right? And what's also important, in my calc pay rise procedure, I do not have no queries, 0 queries, no select, no update, nothing, just pure PL/SQL. Right, and I have my main table, main procedure. I use book collect to take all my employees to the collection. I run a calc pay rise procedure. Remember, there's no query at all. And at the end, I use for all to update, but only once, all my employees. Let's run it. 0 seconds, so almost nothing. And you can check in $SQL. This is from $SQL counts, executions. So we see that I queried department table only once. I queried EMP table only once, and I updated EMP table only once. And my context switching is almost 0. So let's look again at this. So in typical process, We get configuration, get data, and process, and DML. And we do this in a loop, right? And another one, another row, and another row, right? So we have a lot of queries and updates. Query, update, query, update, query, update, context switch, context switch, context switch, context switch, and so on. And batch processing scheme we can do using PLSQL collections. We can load our configuration as a first step in our processing and load all configuration to collections. Then process, query all main data, for example, employees, right, to also collections, and then run all processes we need using only PLSQL code. And if we need some configuration, we can take them from collection. If we need some data, we can take them from data collections. And at the end of all processes, we can update those records with new values using just for all. So SQL is great, but we should use it less and be careful. So that's all from me. And if you have any questions, you can ask now. Okay, so thank you very much. Oh, there's some cool. This is time for answer queries, right?
Yes, Monica, did you see the questions in the
Yes, I've noticed them right now.
Yes, thanks.
Okay, we have nightly jobs that very often get aura. Okay, I can't answer this query right now. I have to check. I don't remember how we can fix it. Yes, another commit after each row also slows the process beside the logical problems. That's also the true. We should reduce commits and it will be also faster, but it's another thing and another story. What is your recommendation for very busy production database, alter index, monitoring usage, or alter session set? No, alter index monitoring usage is old feature. So it was deprecated at 12 or so. In the Oracle versions newer than 12, we have this track index usage and it's still on all the time. And we can only switch between all parameter or sampled. So this monitoring usage is old one. Okay. What are the clips in the slides? Is it from a show? Yes, the clips from the slides, it's from the show IT crowd. Very, very interesting. I recommend it. Okay. More questions, maybe?
Last call for questions. Those are great questions. And Monica, thank you for such a great session today.
Thank you very much.
One more question, I think.
Okay. Does Org index different when using direct path inserts? No. The inserts, when we use direct path inserts are indexes, I'm sorry, are maintained the same way. So direct path doesn't reduces anything when we talk about indexes, only the data. Thank you.
All right. Okay, everyone. Well, if you don't have any other questions, I think we can close out now. But if you do think of something later, we can send them to Monica and she can get back to you as well. So Just let us know anything else you think about in any of our follow-up emails. You should receive an email from me, Monica Lee, or one of my colleagues about when the recording will be posted. So again, you can find it at nyoug.org, or you can find it at AuraPub as a free member. Awesome. Thank you so much. We look forward to having you again speaking for us, Monica, in the near
Thank
future,
you.
hopefully. Awesome.
Thank you very
Okay.
much. Thank you.
We hope
Thank
everyone
you.
has a great day, and we'll hopefully catch you at the next one. Our upcoming webinars include, let's see, I think we've got something about modernizing Oracle Forms with Visual Builder, and then we have another one coming up called Dynamic Mechanisms of Query Building. And then I think Coleman and I are on a mission to fill up the calendar
Yes.
beyond that. So we might see Monica again very soon.
Thank you, everybody, for participating today in today's webinar.
Yes. Thank you so much. And thank you, Monica, for speaking.
Thank you.
Take care, everyone.
Bye now, everybody. Thank you again.